In this video, you are going to learn how to assign oxidation numbers. We are going to learn oxidation reduction reaction, and in order for us to understand this oxidation reduction reaction, we need to understand how to assign oxidation number and what is oxidation and reduction. I can give you a heads up now. Oxidation, that means loss of electrons, and reduction means gain of electrons. We'll learn more about that reaction. But first begin with, how do we assign oxidation numbers? We have to follow all these rules. The first rule is the oxidation number of an atom in an elemental substance is 0. Another way of saying that is an atom or a molecule in its elemental form, that will be equal to 0. I'm going to give you some examples. Let's say oxygen molecule, O2. What is the oxidation state? It will be 0. Why? Because it just have one kind of element. So that's why it's called in elemental form. Let's say we have water molecule, H2O. What about this oxygen? Is it in its elemental form? No. Why? Because it's combining with another element, so it's not in its elemental form. Another example, let's say I have sodium. So what is the oxidation state of sodium metal? It's just one element, so in its elemental form, therefore the oxidation number is 0. What about NaCl, like this? All right, now we have more than one element in it, therefore this we cannot call this elemental form, therefore it is not 0 over here. All right, so let me make it clear again. For the elements that is in its elemental state, the oxidation number is 0. Sometimes we have another word for oxidation number that is called oxidation state. They are the same. Oxidation state and oxidation number is the same thing. All right, let's look at rule number 2. The oxidation number of a monoatomic ion is equal to the ion's charge. Let's look at this one. If I have sodium chloride, that is a table salt, dissolved in water, okay, what we get will be Na plus and Cl minus. Even if it's not dissolved in water, just any binary ionic compound, what we can see is the oxidation state will be the same as its charge, because here sodium will be positive 1 and chlorine will be negative 1. All right, so let's look at another one. How about calcium oxide, CaO? Calcium is from the second group, that's alkaline earth. So therefore the charge will be positive 2. Oxygen is from the group of chalcogen and therefore is minus 2. These are the charge and at the same time is the same as the oxidation number. Okay, let's look at other things. For example, let's say potassium chloride. Potassium is from the first group. When it becomes an ion, it will become positive 1 and therefore the oxidation number is positive 1. And chlorine is from the halogen, group number 17. The charge will be minus 1 and therefore the oxidation state is minus 1. Okay, let's go to rule number 3. It says, for hydrogen over here, when it combines with a non-metal, and the oxidation number will be positive 1. Let's look at an example. Hydrogen with a non-metal, let's say hydrochloric acid, chlorine is a non-metal. So the combination like this, hydrogen will be positive 1. And therefore, because the whole thing is neutral, and chlorine will be negative 1. Let's look at another example. just take water as an example now, H2O. Oxygen is a nonmetal, and when hydrogen combines with an oxygen, therefore the oxidation number for hydrogen will be positive 1. So what about oxygen here? Because the overall charge should be 0, and therefore it must be minus 2. Okay, I think it is clear now. What about when hydrogen is combined with a metal? For example, if I have sodium combining with hydrogen, what is the oxidation state for hydrogen now? It says it is negative 1 when it combines with metal. So in this case, hydrogen, the oxidation state will be negative 1, and sodium will be positive 1. If you look at this, the overall charge or the overall oxidation state, it will be 0 because it's neutral. This molecule is neutral. Okay, so we're good with hydrogen. What about with oxygen? For most of the compounds, oxygen will be minus 2. Let's look at the water molecule over here. It is minus 2. Okay, let's look at another one, calcium oxide, for example. Calcium will be positive 2 and oxygen will be negative 2. And the overall charge for this compound is 0. There's no net charge on it, just like the water molecule is 0 charge. How do we know whether there's charge or not? It will be indicated somewhere. For example, if I tell you that is, let's say, is OH minus. In this case, we know that O and H together, they are going to carry a negative 1 net charge. All right, so most of the oxygen, the oxidation state will be negative 2. I say most of them, so there must be some exception. The first exception is when it is in its peroxide form. So what is the peroxide form? Peroxide always comes with O2. Okay, so the most popular one will be H2O2. So this O2 together is going to carry a minus 2 charge. Usually just a single oxygen will carry a minus 2 charge. But now, 2 of the oxygen together, it will carry a minus 2 charge. That means the oxidation state for each atom over here will be minus 1. Okay, so hydrogen peroxide is the most common one that you're going to see in the peroxide form. You're going to see that you can buy that from a pharmacy. Usually in a pharmacy is about a 3% or 1.5% and 3%. That is very common for the hydrogen peroxide that they sell in a pharmacy. Okay, so what's the next exception for oxygen? When it forms a peroxide, okay, so what is a peroxide? It will have the O2 to the minus form. So let me give you an example of the superoxide. For example, if I have KO2, so this is potassium superoxide. You have learned from the previous chapter before, when potassium combines with an oxygen, usually it will form potassium oxide. Potassium oxide is K2O. Okay, so under normal condition, it's going to form K2O. Why? Because potassium is from the first group, so it carries a positive 1 charge, and oxygen is from group number 16. That's the chalcogen group, so it carries a minus 2 charge. And now you have 2 positive and a minus 2, so add up to be 0, so it's neutral. So potassium oxide supposedly will have the formula of K2O. Now, if you have a formula of KO2, so we cannot call this potassium oxide. In fact, this is potassium superoxide. In this case, potassium will be positive 1, and because it's a superoxide, and therefore this O2 is going to carry a minus 1 charge. Look at this, O2, 2 of them together will have a minus 1 charge. That means the oxidation state for each of oxygen will be a minus half. Okay, let's look at the chart over here. So peroxide, each oxygen will carry a -1 charge. Superoxide, each oxygen will carry a -½ charge. Okay, let's look at the next rule. Now it's about halogen. Okay, for halogen, normally it is -1. Always for the fluorine, it will be -1. Okay, so when will be the exception? Okay, so for example, when it combines with the for oxygen, you can see exceptions. Okay, so let's review some of our previous knowledge. We say there are 6 strong acids. One of them is the perchloric acid, that is HClO4. If you look at this one, that means H is a positive. That means this whole anion will carry a -1 charge. That means the perchlorate ClO4 altogether will carry a -1 charge. Since oxygen typically carry a -2 charge, so over here, each oxygen should be -2. If you add them up, over here you should have -8. What will be the one for Cl? Because Cl and the 4 of the oxygen should add up to be -1, and therefore over here the chlorine will be +7. So it is not a -1 anymore. Okay, let me repeat what I just said again. The halogens, most of the time, it carries a -1 oxidation number. But when it combines with oxygen or other halogens, it is possible that it is not -1. And here is an example. When you have ClO4, and the whole thing is going to carry a -1 charge. So what is the oxidation state for chlorine over here? For oxygen, it will be assigned as -2 because we try to follow the rule over here. For oxygen, most of the compounds will be -2, and it's not a peroxide, it's not a superoxide, therefore it will be a -2. I have 4 oxygens. If each of them is -2, and therefore oxygen only, I will have -2 multiplied by 4. Then I will have the charge of -8. But the net charge, the overall charge for the whole polyanion is -1, and therefore the chlorine over here, it must be +7 because +7 plus a -8 will be equal to the net charge of -1. Okay, and what is the 4th rule? It says the sum of the oxidation number for all atoms in a molecule or a polyatomic ion equals to the charge of the molecule of the ion. We just have shown that. Okay, let's work on some problems. Let's work on problem number 25 over here. Okay, so Cr, chromium, okay, what is the oxidation number? So this polyatomic anion will carry an overall charge of 2-. Okay, so now let's look at it. Oxygen is -2, that is the rule. How many of them? 7. So just by oxygen I have -14, but I need to come up with the overall of -2. So what I can do, this one altogether must be 12, +12, and each, because I have 2 chromium, and each of them must be +6. Okay, let's look at the next one. So how about this one? Manganese, oxygen, overall -1. Okay, so oxygen is -2, and I have how many? I have 4. So I have -8, and how it can become a -1, and therefore this one